MPLS TE and MPLS VPN. In this video, again, I'm going to talk about the relation between the MPLS TE and also MPLS VPN when we have PE to P tunnel. The first question is that why we need to configure the PE to P tunnel, and after that how we can configure it, and what is the, for example, issue about the PE to P tunnel. Let me first talking about the usage of the PE to P tunnel. Look at this scenario. In this scenario, again, we have customer A with two sites, site 1 and also site 2, and we need to connect these two sites together. And this is a service provider. In this service provider, we have multiple paths. Assume that in service provider we are using OSPF, and you know that the OSPF should select the best path with the cost. And here we are using only the fast Ethernet interfaces. You know that the fast Ethernet interfaces cost is 1. Because of that, here we have for example, a scenario with the unequal cost between two paths. For example, the path from router 2 has cost 2 to router 3, but the path from the router 2 to router 4 has cost of 1, the default cost. And because of that, the only traffic should be sent from this path. And here we have a path without any traffic. I'm going to configure a TE tunnel for sending the traffic from this path to router 3, and after that from router 3 we can forward the traffic to the destination. In this scenario, we are using only using and working only on one example. Maybe in different scenarios you will encounter with the same problem, but in different, for example, situation. Because of that, we can and we should configure tunnels between the P and P routers for traffic engineering, for better usage of the bandwidth on the links. Here in this scenario, I'm going to show you what is the problem, what is the limitation of the configuring the PE to P tunnel. You know that in previous scenario, we learned about the configuration of the, for example, T tunnels between two P router, R1 and R6. Here we don't have any problem. Why? Because from the next P router, okay, for example, from R6, we receive the BGP label, VPN label, and after that we have a tunnel to that router. We can forward the traffic with two label, the BGP label and means with the VPN label, and also the for example, RSVP label. We don't have any problem. But when you are configuring a tunnel between the router 1 and router 3, means a P and another P, you will encounter with a problem. Let me to talk about this. Assume that here in router 8, we have 192.168.254, okay, 2548/32, and also in the router 7, we have the loopback of 192.168.254.7. We need to connect these two loopback IP address to each other. And because of that, we are using between the customer and provider eBGP, okay, as you learned in the previous scenarios. And also between the R7 and R1, we are using eBGP. Because of that, the eBGP can send this update to R1. Let me to show you. This is the for example, R1 receiving this update. Let me to change the color of the update. Now the R1 should forward this update only to the R6 because we have BGP neighborship with the router 6, and you know that here we need to convert the IPv4 to VPN v4 with the RD. Here we have VPN v4 and the RD is 65,000 column 1, for example, and then column 192.168.2547. Here we need to send the next stop of the router 1, 192.168, okay, 168.2541, and also for example RT again 65,000 column 1. That's it. Okay, this address should be received with the router 6, and finally router 6 should import this update to its BGP table, and then it can forward the update to the R8 after AS overriding. That's it. This is the scenario that you learn about it in the MPLS layer 3 VPN course. After that, we have another update from the router 8, 192.168.254.8/32 should be advertised to router 6. Again, because we have BGP neighborship between the router 6 and router 1, we can advertise this update to the router 1, okay, as a VPN v4 routes. with the, for example, RD of 65,000 column 1, then the address is 192.168.2548/32. The next stop is 192.168.2546, for example, and the RT is 65,000 column 1. And finally, we can advertise this update to the R7. Now, we have a pass between the R7, we have, for example, a complete control plane between the R7 and R8. But let me to talk about the, for example, this tunnel. You know that when you are configuring the tunnel between R1 and R3, you will receive a label with RSVP. Let me to show you. This is the label that we are receiving from the RSVP. For example, we are receiving RSVP label of the POP from the router 3. Okay, this is the RSVP label. Let me to write here. This is the RSVP label, RSVP POP, okay? And then we need to advertise a label from router 2 to the router 1. You learned about all of these topics in the previous videos. RSVP, for example, label 200. This is the label 200, and this is the label POP, okay? After that, if we receive a traffic from router 7, we can forward the traffic to the router 1. Look at here. Here we have a traffic with the source of 192.168.2547 to the destination of 192.168.2548. This is the real data, okay? Let me to show you the or follow the packet, okay, from here. Now this packet received by router 1. Router 1, you know that should be learn or should learn one label from router 6. For example, router 6 advertises to router 1 the label of 600 with the BGP update, and because of that, router 1 can use this label 600 as a bottom label. After that, this is the BGP label, you know it, okay? After that, we need a label to the, for example, router 6, but you know that here we didn't configure the tunnel between the R1 and R6, and also we don't have LDP. If you send the traffic with the label of the, for example, RSVP, for example, we are forwarding this traffic to the T tunnel, we will forward this traffic with label 200 to router 2, and then router 2 should swap the label, okay, to the, for example, POP. And after that, now we forwarded this packet to the router 3. But router 3 doesn't know about the 600 because the router 3 doesn't advertise or didn't advertise the 600 to R1. Okay, because of that, now we have a problem. R3 cannot forward the packet to the destination. You know that the 600 is the BGP label and the 200 is the RSVP label. We don't know about the label that we can use that label to reaching to the R6. Here we have a problem. In the previous videos, you learned that we configured one tunnel between the R1 and R6 because we had a label to reach to R6 with the T tunnel. Because of that, we could send traffic to the R6, and finally R6 can use the 600 to forward the traffic to the destination. But here we don't have a pass to R6, and because of that we have a problem. And how we can solve the problem? Let me first explain the function that is happening. After that, I will give you two methods for solving the problem. The need of us is that when this traffic receiving in R3, okay, R3 should use this the labels of this traffic to forward the packet to the R6. Let me to say that when you are configuring the PE to P tunnel, the P to P tunnel, okay, such as this scenario, PE to P, you need to configuring LDP. You know that in previous scenarios, I said that we don't need configuring the LDP, but here we need LDP. Look at here, let me write here. When we have PE to PE, okay, for example, a tunnel, we don't need LDP, we need only RSVP, that's it. When we have, for example, VRF, okay, to PE tunnel, VRF to PE tunnel, we need again only RSVP tunnel. We need only RSVP and also BGP, okay? And here in the PE to P, as I mentioned before, we need LDP. Let me to show you what is the function.